We go. We are off. Rockot is hauling itself against the gravity of our planet. The first stage is pushing us away from Earth. We need a lot of firepower to do that. Nick, what's our trajectory?
So at the moment we're heading north-northwest, so we're heading up over the Arctic Ocean, and we're heading in this directory because we want a polar orbit when we finally separate, so that Sentinel-3 will be roughly 98 degrees in inclination, which is the angle from the equator to the orbit.
Philippe, what's happening to your satellite right now?
Well, it's starting its journey. I can tell you it's always a little bit of an emotional moment. Huh? I think that launching a satellite in orbit is similar to launching a ship at sea. You know, you have worked for it, you've waited for this moment, and here it comes. Very beautiful pictures that we've been able to witness, I have to say, with a clear sky and voila. We also get, I mean, I think that everybody's been able to see the strength that there is in this launcher. You know, our satellite, once it's in orbit, is in a very smooth environment for what concerns at least the mechanical environment, because it's just floating in the air once up there. But now, for this launcher, you can see with this big boost and all the vibration that goes to it, it's a very bumpy ride, really. It's
It is in the first phase of the flight, isn't it? But right now we have separation of the first stage. We're now burning the second stage, Nick.
Yep, this burns for about 3 minutes and it takes us right over the North Pole, and at the moment we need to accelerate. So we've gained a little bit of altitude, but we need to go fast enough so that when we stop burning we can actually stay in orbit.
And if you look at the front of the launch vehicle, you can see here what we call the fairing. Nick was referring to that earlier. It's the pointy section of the launcher. We don't need it anymore because we are now in space. We've gone through the dense part of the atmosphere and we can jettison that. Philippe, we can see your satellite now for the first time.
yes, but those are simulated pictures, yes, but indeed this is what we can imagine, which is that the spacecraft that the teams have seen for the last time when the fairing was closed around it is now really starting its journey in space, because it's really up there and in the forefront of as a spearhead of the Breeze launcher.
So we've gone above what's often known as the Kármán line, which is effectively the border with space. It's about 100 kilometers above sea level, 62 miles. What does that actually mean, Nick?
So at this point the air is so thin that the force required to fly in an aeronautical regime, so like an aeroplane does, is more than actually a rocket needs to fly in an astronautics domain. So this is really the rocket science that needs to keep us there, and it's the boundary between aeronautic ending and astronautic beginning.
And it was identified by a Hungarian-American aerospace engineer called Theodor von Kármán, and he was born in 1881. So we're burning the second stage, getting closer now to the next phase, which will be the second stage shutdown. These images that we're looking at, these are computer-generated images, which are a simulation of what's been planned for the flight. The experts put a lot of information into the computer to generate them.
Flight dynamics of the loop.
And the second stage shutdown is coming up.
The lift-off time was 1757.51.
And this is the scheduled moment now for the upper stage to switch off and switch on of the breeze upper stage. So we've lost the second stage, we've switched on the breeze upper stage, we're starting the next part of the journey. Breeze is taking the wheel, Philippe. It's going to take, what, about another hour and 15 minutes from now. What's Breeze's job?
Well,
Dynamics of the loop.
the Breeze has the important task to bring our satellite exactly on the precise orbit where it should be. In our case tonight, we want to be at the same altitude than Sentinel 3A, just a little bit above for the commissioning phase, 10 kilometers above actually. So the satellite has its own engine and can change its orbit, but this costs fuel, and so it's very important that we have a precise orbit right from the beginning, and that's where it's critical to have a performant and let's say on-target third stage like Breeze will very likely do tonight.
It's a little bit like a sophisticated taxi driver. It takes its passengers where they need to go. Nick, it's a fascinating piece of kit, isn't it? Because it's effectively a spacecraft in its own right.
Absolutely, yes. It has to be very autonomous, so it has to really think for itself and be able to decide when to do exactly what it has to do. It has its own onboard computer with guidance, navigation, control. It has its own tracking and telemetry system, so it can talk to the ground and tell the Russian experts what it's doing and when it's doing it. It actually has the capability to restart its engine multiple times and perform different maneuvers so that it can take its passengers to different orbits or even multiple satellites to different orbits. So it offers tremendous flexibility, but as you say, it has to be very clever, and it's a spacecraft in its own right.
The Sentinel-3 satellites are a key component in the Sentinel constellation, which of course as a whole provides vital services to the Copernicus program. We're going to take a look now at the kind of services that the Sentinels provide.